Almost ready, guys. Just want to put the link on the website, and then we'll jump into this. Okay, get your book out. Okie dokie. It sure is. Okay, where were we? So we were looking at completing a square. We were just about to do that. And okay, we're waiting. Breakfast? Oh my gosh. Okay. All right. Okay. Let's jump into this. So yesterday we talked a little bit about. Actually, no. Before we jump into this, I just want to mention I marked your assignments. I'll be putting the solutions up shortly. I had meant to be finished the solutions some time ago. I thought that I'd already finished them, but I went to go post them yesterday, and then I realized I hadn't actually saved my work, so I got to do the solutions again. So so stay tuned for that. But yeah, if you have any questions about the like your mark, how I calculated your mark or whatever, don't hesitate to ask. So pretty much it's out of 10, but on Google Classroom, but Google Classroom is I just, for some reason, I made it out of 100, so everyone gets a mark out of 100. And because there was 10 questions, and question 6 was not a question, everyone got a mark for question 6, so it's out of 10. So the lowest possible mark is 1 out of 10, because you would get that anyways from question 6. So yeah, check Google Classroom, see what you got, and if you have any questions, reach out. Another thing too, I should point out, tomorrow is Good Friday, so yeah, keep that in mind. Tomorrow's Good Friday, so we don't have class. My stream is pixelated. I don't know. Is it pixelated for everybody? Oh, that's not good. Oh, yeah, it is, isn't it? Yeah, we'll go over 90. Okay, let me see if I can, oops. Yeah, it is pixelated, isn't it? It's supposed to be 720. Okay, I'm gonna log out. It's still, huh. That's not good. Yeah, it looks awful. Dude, it shouldn't be super pixelated like that. And it's still pixel. Oh my gosh. I have no idea why that is happening. We might just have to deal with it today. If you want, what you could do is you could do something like this. Here, let me just get my screen ready to go here. Because on YouTube, I think it's fine. YouTube seems to be just fine. Yeah, so looks like just 2 people are on YouTube right now. But what you could do is you could do something like this. You could kind of like, I don't know, maybe you're on mobile, so it's not as good. But you could kind of like do like a here. I'll show you what I'm talking about. I'll do this. You could do something like this, right? This looks super confusing. Oh my gosh, this is kind of silly. But I think you get the idea, right? That you could like have Discord on one side of your screen, and then have YouTube like a nice high quality. Wow, this looks crazy. I'm gonna stop doing that. But maybe you can just watch the stream on both platforms if you want. I don't know, because I don't know if I can fix that right away. I'm sure I could figure it out eventually, but I mean, we're live, right? We only have 45 minutes. So yeah, maybe head over to YouTube. I know that there's a bit of a delay, but you could still, use your headset and just leave Discord on. So yeah, sorry if it's a little pixelated. I'll drop the link in the I am on YouTube. So there's the link there. So if you want to head over to YouTube to watch the stream, you can do that. Anyways, yeah, yesterday we were talking about rationalizing the denominator and what that means and why we do it. But we didn't actually really do very many examples. So let's do a few more examples. So I'm gonna do. Yeah, let's do something like this. Yeah, I'll just do some from the textbook, and then we'll pretty much call it a day, because that's pretty much all I wanted to do from 5.2. So we're making our way through the book, which is great. So let's see here, rationalizing the denominator. So let's do some examples. Rationalizing the denominator. Okay, so yeah, let's do. I'll just kind of make some of my own questions up. So let's say that we want to rationalize this guy. So let's say that we've got 2 times the square root of 3 over the square root of 5. Okay, let's say that we've got that one, and we want to rationalize this denominator. So what we would do is we would multiply this by root 5 over root 5. So I've got 2 root 3 over root 5 times root 5 over root 5. And what we get after that is, well, I've got 2 times the root 15 over, well, root 5 times root 5 is just 5, which is the whole point of doing it in the first place, right? Is to get rid of that square root of 5. And that's that, and we're done. So rationalizing the denominator can be very straightforward. It can be simple, but it can also sometimes be a little more challenging. And I'll show you some other examples that are more challenging in a minute. Let's try another one. Let's do something that looks sort of like this. So let's do this one. Let's do 4 times the square root of 7 over, let's do 3 root 6, okay? 3 root 6. Okay, so this one, keep in mind that we're just trying to get rid of the radical. We're just trying to get rid of that square root symbol. We're not super concerned about anything else. We just want to know what the we just want to get rid of the square root, so I'm a little distracted right now. So yeah, what I'm going to do is I'm going to write the whole thing out again. So 4 root 7 over 3 root 6, and I'm going to multiply the top and bottom by root 6. So root 6, I'm going to multiply that. Okay. So I've got 7 times 6 is 42, so I've got root 42 all over. Well, 3 times root 6 is 3 times 6, okay? And well, now I can start to simplify this a little bit because I can see a 2 on the numerator and the denominator. So this cancels with this, and I got 2 left over here and 3 left over here. This is equal to 2 times root 42 over 3. And I don't think that we can simplify the square root of 42 anymore. That's pretty much done. We can't simplify that anymore. So yeah, I think that's pretty much it. So let's do a question that's maybe a little more challenging. So let's try to rationalize something that looks like this. So let's do yeah, I'll do this one from the book. You know what? Actually, before we do that, I better tell you about conjugates. Okay, so, oops, whoa, what happened here? Okay, grade 11 pre-cal. There we go. Okay, so let's work on some conjugates. Let's talk about conjugates. Okay, so conjugate. This is a new word. So the conjugate of a plus b is a minus b. Okay, that's all it is. And the conjugate is a really handy tool because it really can help you sort of get rid of certain types of numbers that you don't want. Currently, we don't want radicals. Radicals are the things that we're trying to get rid of, but you'll find if you end up studying math later in university that there's other types of conjugates, like the complex conjugate, that help you get rid of certain complex numbers. So there's all sorts of different types of conjugates that can really help you get rid of certain types of numbers, which can be very handy. So for us, we want to get rid of radicals, so we can use the conjugate to do that. And it seems a little bit weird to just have this like a minus b, but you'll find that it's useful, and it's useful because I'll just write note. If I take an expression a plus b, and I multiply that by its conjugate, a minus b, let's see what we get. Well, you may remember this as being a difference of squares from our last section. So this would be a times a, which is a squared, and then we would have a times b, or sorry, a times negative b, so that's negative ab, plus b times a, or plus ab, plus b times negative b, or in other words, negative b squared. And you'll notice that I've got minus ab and plus ab, which gives us a squared minus b squared. So that's really handy, because if one of these was a radical, like if a was a radical, like maybe a was like the square root of 3 or something, and we wanted to get rid of that, well then all of a sudden we'd be squaring the square root of 3, which would give us a whole number back. So that would get rid of that irrational part of the number. So keep that in mind. So that's how we use conjugates to our advantage here. So let's do an example where we use the conjugate. So let's do, I'll just copy this one from the book. So let's do 5 root 3 over 4 minus root 6. Okay, so I've got 5 root 3 over 4 minus root 6. Okay, so that, well, what I'm going to do is I'm going to write the whole thing out again. So 4 minus root 6. And here I'm going to multiply by the conjugate of the denominator. So here's my conjugate, okay? Or sorry, here's my expression. I'm going to multiply by the conjugate. So the conjugate of this, the conjugate is I keep the first number the same, but I change the sign of the other one. So the other one is going to be plus root 6 now. So I'm going to multiply the top and bottom by 4 plus root 6, and then 4 plus root 6 on the bottom. And what we're left with is, well, I'm going to use the distributive property here. So I've got 5 times 4 times root 3, so in other words 20 root 3. And then I've got 5 root 3 times root 6, so this is going to be 5 times the square root of 18. Okay, And then on the denominator, what I have is, well, I've got 4. Remember that these will be in brackets, so I'm multiplying all of this together. So I've got to use the distributive property here. So I've got 4 times 4, which is 16. I've got 4 times root 6, so 4 root 6. And then I've got negative 6 times 4, which is negative 4 root 6. And then finally I've got negative root 6 times positive root 6, which is minus 6. Okay, you'll notice these cancel out, and now the denominator is rational. I can add it without any troubles. So let's rewrite the numerator. I've got 20 root 3 plus 5 root 18, and in the denominator I've got 16 minus 6, which is 10. And look at that. Now I have a nice denominator that is rational. I'm still not done simplifying it yet, though, because the square root of 18, I can simplify that. I can still simplify that. So let's go ahead and kind of focus our attention on that. So I know that 18 is equal to 2 times 9, and 9 is a perfect square. So we can pull that out and take the square root of it. So this is equal to 20 root 3 plus 5 times root 9 times root 2 all over 10. And that is equal to 20 root 3 plus, well, that would be 18 root 2 all over 10. And that's pretty much it. However, I can simplify this a little bit more. I can simplify it a little bit more. So what I'm going to do here is I'm not sure where the 18 came from. Thank you. That should be 15. Yeah, because 5 times 3 is 15. So yeah, that should be 15. Okay. So one thing that you might notice is that both of these have, like, all of these numbers, the 20, the 15, and the 10. They all have a common factor. So I'm going to multiply the top and bottom by a fifth. So I'm gonna take this and multiply it by 1/5. And I'm gonna take this, I'm gonna multiply it by 1/5. And the reason I'm gonna do that is because basically I'm just gonna take all of the numbers and divide them by 5 because I can, and that'll help me reduce it a little bit more. So 20 divided by 5 is 4, so I've got 4 root 3. 15 divided by 5 is 3, so I've got 3 root 2. And then 10 divided by 5 is 2. So all of those terms had a factor of 5, and so I just factored 5 out from the numerator and the denominator, and then canceled them out. So yeah. So that's pretty much all there is to it when it comes to rationalizing the denominator. There's some that are going to be very straightforward, where you just multiply by whatever the denominator is. Like if it's just a radical, then you're pretty much just done. And if you have like a sum or something like this, then you multiply by the conjugate. And that's really as like there are some situations where it gets a little more complicated than that, but I can't sit here and just walk you through every single possible outcome that you can think of. So at some point you actually do have to try these for yourself. But I'll do a few more from the book just to get us warmed up, and then we'll call it a day. So we'll have a nice little long weekend and have some time to relax. And okay, so let's try this one. I'm gonna do this one here. So, and this one is from page. This is from page 287. 287, and this is number. I guess it's not numbered. It's just question A. Okay, so I'm gonna do it. I'll do maybe all 4 of these. And then there's a few that they want you to do as well. So let's do 4A, or sorry, just question A. So we have the square root of 24x squared, all over 3x. Square root of 3x. And they're saying that x here is greater than 0, which is nice for two reasons. The first reason is that if x was equal to 0, then you would be dividing by 0 on the bottom, right? In fact, you would have, like if x was 0, then you'd have 0 over 0, which is a major problem. Another thing that's useful about this is that x is positive. So not only is it not equal to 0, but it's larger than 0. It's greater than 0, strictly greater than 0. So that's nice, because if it wasn't, like if it was negative, then this bottom radical, like this would be negative and we'd be taking the square root of a negative number. So I'm glad that we're not having to worry about negative radicals or anything like that. So I'm going to copy out this whole question again. I've got 24x squared all over the square root of 3x. Okay, so that looks good. Okay, and oh boy, so I'm going to multiply this by root 3x over root 3x, and that's going to take care of everything pretty much. So I've got, well, 3 times 24 is, I think, 72. So I've got the square root of 72x cubed on the top, because x squared times x is x cubed. And on the bottom, I've got, well, root 3x times root 3x is just 3x. So there you have it. So this one wasn't too bad. I'm wondering if I can reduce this 72x. So 72. I'm wondering if we can factor out any perfect squares from 72, and I think that we can. So what I'm going to do is I'm going to write 72, and I'm just going to do a factor tree. So I know that 72 is, I like to think of it as 6 times 12, right? And 6 is 2 times 3, right? These are prime. And then this would be 2 times 6. And here we have 2 times 3. So what I'm going to think of doing is I'm going to sort of think of pairs of prime factors. So I've got 2 2's, and I've got 2 3's, and then a 2 left over. So that means that 72 is equal to, well, it'll be 6 times 2, or in other words, 6 squared times 2, which makes sense, right? Because 6 is 36, and 36 times 2 is 72. So that worked out pretty nice. Okay, so that's that. So I'm going to factor out a 36. So I've got the square root of 36 times the square root of 2x cubed all over 3x. And this is equal to, well, the square root of 36 is 6. So I've got 6 times the square root of 2x cubed all over 3x. And oh, look at that. Now these cancel out. Boom, boom. And I'm left with 2 over here. So this is equal to 2 times root 2x cubed all over x. Okay. So that's that question. So we're done with that. Awesome. Yeah. Actually, that's a really good point. Yeah, that's a very good point. So yeah, I factored out the 72. I factored the 72, but I forgot that we actually have other perfect squares in here, right? X cubed, don't forget, x cubed is equal to x squared times x. So yeah, there's definitely some perfect squares in x cubed. So let's get as many of those perfect squares out. So this is going to be equal to, well, if I take the square root of x cubed, that's going to give me the square root of x squared times the square root of x. Square root of x squared is x. So this is going to be, x root x. So this is going to get, finally, 2x times 2 root 2x all over x. There we go. That looks a bit better. Okay. Yeah, those x's would cancel each other out. Yeah, yeah, good point. So this is 2 times root 2x. Look at that. So so this one collapsed quite a bit. Like if we take a look at, like, there's the original question had not only like a numerator and a denominator, but it like had a radical in the denominator. It had these big numbers, right? So yeah, this one collapsed down quite a bit. I want to quickly just show you that there's another way that we could have done this one that could have saved a fair amount of time. Okay, so bear in mind that we could have done this in a much easier way without even rationalizing the denominator. Like watch this. So this one's equal to root 24x squared over root 3x. Okay, and a radical divided by a radical is the radical of that fraction. So I've got, this is the square root of 24x squared over 3x, right? Boy, wouldn't that have been easier if we had just done this, right? 24 goes into, 3 goes into 24 8 times. So this is 8x, the square root of 8x, because the x and the x squared cancel out. So I'm left with 8x. And then this, I could factor out a 4, and we would get 2 times root 2x. So this way would have been much, much faster. But I think that we were kind of had our sights on the rationalizing the denominator. So we kind of did it in the long way. But there's nothing wrong with doing it like this. Like, this is perfectly fine. We absolutely got rid of the radical in the denominator. So we're fine. We're fine. Okay, let's do another question. Let's do question B. Let's do question B. So question B is, okay, 4 times root 5n over 3 root 2. 3 root 2. And here they're saying that n is greater than or equal to 0. So you'll notice that the last one, x was strictly greater than 0. This time n is, we say it's weakly greater than 0 because it could be equal to 0, but it's certainly not less than 0. And the reason for that is because here it's okay if n is equal to 0. If n is equal to 0, the only n that we have in this expression is here. So if we had 5 times 0, then we would have the square root of 0. And you're allowed to take the square root of 0. It's just 0. And then you would just have 0 in your denominator, or sorry, your numerator, which is fine. So in the last question, we couldn't have our variable equal to 0 because we had the variable in the denominator, and you can't divide by 0. So, okay, so let's take a look at what's going on over here. So let's rationalize this denominator. So let's multiply the numerator and the denominator by root 2 and see what happens. So this is going to be equal to, well, I'll do 4 times root 5n over 3 root 2, and I'm going to multiply the top and bottom by root 2. So I'm going to multiply this by that. Okay, so that looks good, and maybe I'll just have one multiplication sign. There we go. Okay, so when I do that, I have 4 times, well, root 5 times root 2 is root 10. I've got root 10 times n. And in the denominator, I've got 3 times, well, root 2 times root 2 is just 2. So I've got 3 times 2 in the denominator. And this will cancel with that, so I'm left with 2 on the top. So now I have that this is equal to 2 times the square root of 10n over 3. And I don't think I can do anything after that. I think that we're done there, because 10 doesn't have any square factors, right? It only has 2 and 5 as factors. So I think we're done on that front. So that one was actually quite a bit easier than question A. Let's do question C. C is a good one. Let's do question C. Here's question C. Okay. Okay, where's question? Here it is. Okay, so question C is 11 over, oops, the square root of 5 plus 7. Okay, we've got the square root of 5 plus 7. Okay, so this looks like one where we need to use the conjugate. So let's go ahead and do that. So when I use the conjugate, I'm going to need to multiply the numerator and the denominator by 5 minus 7, or root 5 minus 7. So we got root 5 minus 7. When I do that, you'll notice that I'll use the distributive property for both of these. So on the top, I get 11 root 5. So I've got 11 root 5 minus 11 times 7. So that would be negative 77, we'll see in a second. Okay, and here I've got root 5 times root 5 is 5. This time I'm going to skip a few steps because I know that if I do the distributive property properly, I will have root 5 times negative 7 and positive 7 times root 5. So those will cancel each other out. And that's the whole purpose of using the conjugate, is that these things will cancel out. And all we're left with is root 5 times root 5 and 7 times negative 7. That's the whole point of using the conjugate. Okay? There's literally no other reason to use the conjugate. So in this case, I've got 5, because I got root 5 times root 5, and then I've got negative 49, because that's what 7 times negative 7 is. Next up, I've got, okay, well, let's start to clean some of this up. I've got 11 times root 5 minus 77 all over, well, 5 minus 49, that is negative 44. And just like in that, like a couple questions ago, all of these have a common factor of 11, right? 11 goes into here, 11 goes into here, and 11 goes into here. So all of the terms have a factor of 11. So what I'm going to do is I'm going to multiply the numerator and the denominator by 1 over 11. And when I do that, I get, well, this 11 cancels with that 11. This 77, I have 7 left over. And then this negative 44, I've got 4 left over. So this gives me root 5 minus 7 over 4. And that's that. We're done. Okay. Yes, negative 4. Thank you. Thank you. I just saw my 4 there, and I forgot to write the minus sign. Yeah. So that would be negative 4. Exactly. Yeah. Yeah. So let's just make something clear here. Okay. So when do you use the conjugate? Well, the time that you use it is when you have a sum in your denominator. Okay, so that you only use it when you have a sum in your denominator. So in this second one, right, over here we had a sum in our denominator. So so that's why we use the conjugate. For the other questions, pardon me? Yeah, sum or difference. Yeah, I'll say a sum or difference. Or difference. Okay, otherwise just multiply it by whatever's going to get you a rational number in the denominator. And I'll show you that it's not actually always that straightforward. So I'll show you what I mean here. So let's do question D here. So D is 4 times root 11 over y times the cube root of 6. And here they're saying y is non-zero. Okay, so the thing about this one is that we got a cube root, and that's going to cause us a little bit of trouble. Not too much, but a little bit. So what I'm going to do is I'm going to write the whole equation down again. So I've got 4, make it nice and big, 4 times root 11 over y times the cube root of 6. Okay, so that's what I'm trying to rationalize here. So you might be tempted just to say, okay, well, I've got a cube root of 6, so I'll do cube root of 6 and cube root of 6, and then be on your way. Unfortunately, that's not going to work out very well for us, because you'll find that when I do this, I'm going to have root 6, or sorry, the cube root of 6 times the cube root of 6. That's equal to the cube root of 36. And unfortunately, 36 is not a perfect cube, right? It's not a perfect cube. You cannot take the cube root of 6. Here, I'll show you. Cube root of 6. So, cube root of 6. Hi, Goose. Yeah, see, it's not a perfect cube. So that's our problem. So what we're gonna want, like we have to have a cube root of something here, but it's not going to be 6. We're looking for a value that's when we multiply it together. What are you doing? We're looking for a value so that when you multiply by 6, you are going to get a perfect cube. Well, let's see what we can do to get that. Well, what if I did? Okay, well, I know that I've got a 6 here, right? So oops, what did I do here? My cat is kind of messing with my iPad right now. She's been doing this all day, trying to get attention. That's me. So I know that I've got 1 6 here. Oh, she keeps pressing buttons. I've got 1 6 here. Okay, I've got 1 6. Okay. Well, if I had 6 times 6 times 6, whatever that is going to be a perfect cube, right? It has to be, because there's 3 of them, right? So how about instead of multiplying it by the cube root of 6, what if I multiplied it by the cube root of 6 times 6? Then when I multiply all that together, I'm going to have the cube root of 6 times 6 times 6. And you don't even have to multiply that out, because we're just going to take the cube root of it, right? So I've got the cube root of 6 times 6, which is 36, but it doesn't really matter. So this is equal to the 4th root of, oh my god, my cat is just, okay, 4 times the square root of 11 times the cube root of 36 over y times, well, the cube root of 6 times the cube root of 6 times 6 is the cube root of, well, 6 cubed, right? I've got 6 times 6 times 6, which is equal to, well, let's start to simplify this a little bit. I've got the square root of 11, the cube root of 36, all over y times 6, or I'll write 6y. Okay, so I got 6y there. And it looks like I can cancel some of these guys out. So these have a factor of 2 in common. So I get 2 over here and 3 here. And let's see here. This gives me 2 times root 11 times the cube root of 36 all over 3y. There you go. So yeah, there you have it. So this one was a little more complicated. The tricky thing was trying to find a value that we can put inside our cube root symbol to get that cube root symbol to go away. And we just had to be a little bit clever by choosing the right number to stick in there. And it turned out that, well, we knew that we had 1 6, and since we were going to take the cube root, we had to throw 2 more 6s in there to get a perfect cube out of it. So that's the trick here. And I think a couple days ago there was a request to do a question. was 9d from 5.1. So let's go ahead and do that. So 5.1, 9d. Okay, I hope it's like not too late to do this. Okay, so looks like we got about 4 minutes or 3 minutes left of class. So let's see if we can power through this. So page 279, number 9d. Okay, so we're asked to simplify 2/3 of the cube root of 81 plus the cube root of 375 minus 4 times the square root of 99 plus 5 times the square root of 11. Okay, fantastic. So this looks like a fun one. So we've got the cube root of 81, the cube root of 375, the square root of 99, and the square root of 11. So what we're going to do is we're just going to go through here one by one and simplify these as best we can. So this first one, I've got 2 over 4, yes. Like that, right? Yeah, I think that's right. Okay, so I got 2/3 times the cube root of 81. Well, I don't have to write the whole thing out again. So I think that the cube that I see is 27, right? I think it's 27. So this is going to be the cube root of 27 times the cube root of 3, because 3 times 27 is equal to 81, right? So that's that one. So I'll try to leave some room here, and I wish you could see my cat from that angle. She's being just absolutely adorable. I don't think you can see her. Anyway, okay. Next up, we've got 375. I believe that 125 goes into 375 3 times. So this is going to be the cube root of 125 times the cube root of 3 all over 4. Okay? Because 125 times 3 is 375. Goose. She just wants to play. Poor thing. Oh, poor little Goosey. I don't know if you can see that, but she's trying to play with my little pencil. Goose. Okay. Minus 4 times... Okay, so the square that I see here is 9. So it's 4 times the square root of 9 times the square root of 11. All plus 5. I don't think that I can simplify the square root of 11. It's a prime number, so you can't really do anything with that. Okay, so let's keep going. So I've got 2/3 times, well, the cube root of 27 is 3, so this is 3 times the cube root of 3 plus, well, the cube root of 125 is 5, so I've got 5 times root 3 all over 4, and then I've got minus 4 times, well, the square root of 9 is 3 times root 11, and I've got 5 root 11. Okay, moving right along. So these guys cancel out, and I'm left with 2 times the cube root of 3 plus, well, there's not much I can do here. This is just 5 over 4 times the cube. Oh, this is supposed to be a cube root of 3. Cube root of 3 minus 12 root 11 plus 5 root 11. Okay, and we're almost done here. So I can see some like radicals here. So this 3 root 3 and this 3 root 3 are alike, and this root 11 and this root 11, these are also alike, so I can add them up. And what I'm left with is, here, I'll do the red ones first. So 2 plus 5 over 4. So 2 plus 5 over 4. That's the same thing as 8 over 4 plus 5 over 4, which is 13 over 4. So we've got 13 over 4 times the cube root of 3 minus, because 12, and this is in green, so this portion here, I've got negative 12 plus 5. So negative 12 plus 5 is negative 7. So this is minus 7 times the square root of 11. So I think that one is complete. So yeah, I think that's how you do that one. I haven't checked the answer. What is this, number 9D on page 279? I should double check. Page 279. It is correct? Okay. Okay. So yeah, I mean the trick here is just to take it one term at a time. You can see why I told you last class it's important to memorize these numbers, right? I guess I'll have to add one more number to this list because it came up. 5 cubed is 125. And I'll even do this so it blends in. 125. So so I need you to memorize these numbers because like without that it'd be really hard to do that question, right? So so yeah, let's see if we can memorize these 5 numbers. I know last time I said it was just 4, but I think that this 5th one is a good idea too. Anyway, yeah, I'm gonna sign out now. We went over a little bit, but I think that's okay. So I hope you guys have a nice long weekend. We're gonna come back on Monday, so I'll see you guys on Monday. Yeah, until then, I hope you have a good time. I know it's usually like often a time that families get together nowadays. So I hope that you're able to cope through that and that things are going okay in your life. But other than that, yeah, I'll see you guys on Monday. So yeah, have a good weekend.